All right, so good morning, everyone. My name is Chief Warrant Officer Vic Fernandez. You can just call me Vic. I've been serving in the Army on active duty for about 17 years. While this has not always been the case, my superpowers are cyber defense, DevOps, and now AI. I'm very proud to say I'm a member of the Army's emerging AI workforce. Now, when I say that, the Army has established a new organization called the Army AI Integration Center, or AI2C. We are based out of Pittsburgh, believe it or not. I know a few folks did not believe me when I said I'm stationed in Pittsburgh, but we really do have, go Pirates. But yeah, we really do have an Army element in Pittsburgh, and I am a part of that organization. We're responsible for really three things. One is working with Carnegie Mellon University to make more people like me, AI technicians or AI scholars. Other stuff that we do is developing our own AI products to solve things like predictive maintenance, being able to predict, when a helicopter is going to have a part that fails, or maybe having our own version of ChatGPT, but based off of Army data. We develop those things here in the Army, and then we integrate them across the force. So that is what my organization does. But to be clear, I'm here in a personal capacity. I did submit the request to give this talk to everyone, but then the government shut down, and my unit said, thanks, but no thanks. So paid out of pocket, and now I'm giving this talk here in a personal capacity. Thank you. Yeah, so with that being said, nothing I'm about to share represents the views or opinions of my unit, the United States Army, or the Department of Defense, or if you want to get fancy, the Department of War. For the next 25 minutes, I'll be discussing an app I created called HADES and how it's designed to solve some of the problems me and my peers have had with cyber defense training in the military. In short, HADES is an app for situations where we couldn't afford a red team, and we still wanted to evaluate our blue team skills. Also, to be clear, I made HADES just as a one-person dev. So this is a totally, I made this in my basement, and I'm sharing it now as free and open source software. If anyone has any questions during or after my talk, just come see me in person or send a DM. My handle on Discord, LinkedIn, Twitter, GitHub is the same, and that is Cyber4. All right, so first let me tell you about the experiences of cyber defense in the military and what motivated me to build HADES in the first place. I'll start with Carlos, and I'll kind of step through three different vignettes that, again, motivated me to build HADES. So Carlos is a good friend of mine. He advises 3 security operations centers on how to defend IT services at the tactical edge in a contested region of the world. Obviously, I can't say where these things are happening at, but right now, the only time Carlos can truly evaluate these SOCs is during his unit's pre-deployment activities. Here's how that works. A unit is given the order to deploy, right? First thing that happens. To prepare, the unit visits one of the Army's national training centers. There's 3. One of them's here in California, one is in Washington, and I forget where the other one's at. So they go there, they plan and execute training exercises against an opposing force, otherwise known as a OP4. That includes an offensive cyber capability or just a red team, all right? But here's the catch. Not every unit is able to go to a national training center. A lot of units have to conduct pre-deployment activities locally on site where they are. And when they do, they usually face one of 2 options. One, they just skip the red team because they don't have anyone in their formation who knows how to hack into a network that isn't also on the blue team, or they just pretend there's a threat. That second option is extremely frustrating because the way it looks is during the exercise, your training facilitator will come over to you, hand an index card that says, conduct incident response as if your network has just been compromised. But, but what kind of training value do you get out of that? If there's no telemetry, if there's no logs, if there's no alerts to actually go through, so that's, again, very frustrating. Next, there's Kenneth. Kenneth works at a cybersecurity service provider, or CSSP. He supervises a team of cyber defenders responsible for protecting critical infrastructure in a totally different foreign country than Carlos. Every 3 years, Kenneth's organization is reevaluated on their ability to execute their mission as a CSSP or just really as a managed cybersecurity provider. In practice, this means participating in a very large, very expensive, large-scale training exercise that's hosted by a university in the United States. Unfortunately, it's not always guaranteed there's going to be enough funding or support to pay that university to host this exercise, let alone pay for travel for those defenders to come to the United States or come back to the United States. Finally, there's Andrew. Andrew's assigned to a cyber protection team, or CPT. Andrew and his teammates deploy to undisclosed locations around the world to conduct threat hunting operations. During these operations, Andrew's team is often asked to integrate with tactical systems that they've never seen before. Prior to deployment, Andrew's team conducts training using a cloud-based platform, something that's centralized, at the DoD level. Over time, the training scenarios provided by this platform can become repetitive and eventually irrelevant. They don't change often enough, and they don't involve the types of systems that we see or that we use at the tactical edge. So what do Carlos, Kenneth, and Andrew's experiences, and mine, have in common? It's not just frustration, it's centralization. And when cyber defense training is centralized, at least in our experience in the government and military, it grows three ugly heads. Inefficient schedules, unrealistic environments, and unnecessary complexity. Now, don't get me wrong, centralized training has its place. It's good for what we call a schoolhouse, where we need to train or certify that people know just the fundamentals before they go out and do their job, whether that be in regular IT, cyber, software development, AI. But that's become the only way to gain cyber defense experience in the military. For bureaucratic reasons, this is also the case just across the government. Unless you're special, then it's incredibly hard to train wherever you are as a blue teamer. Let me put this into perspective, all right? This might seem silly, but raise your hand if you have a driver's license. Okay. Now, imagine the only time you're allowed to drive is during your driver's test, right? That is what it's been like for me and my friends in the military as cyber defenders, all right? So, but that's not how you develop a skill set, right? You need driving practice. You need to do it essentially on a daily basis to make sure you're being safe, make sure you know the rules, make sure you're familiar with the roads that you're on, with the environments that you're in, and the things you're trying to protect. You need repetition, practice, and hands-on experience. So what's the fix? The fix is better training capabilities that are available when needed, capabilities that can emulate real threats, run on air-gapped networks or closed restricted networks, and are simple to use. Most importantly, we need training capabilities that don't cost a lot of money or compute. This is how we tame the beast of centralization. Not by waiting for annual exercises or flying people across the world, spending millions of dollars. Cyber defenders need training capabilities that are on-demand, realistic, interoperable, intuitive, and affordable. That's exactly why I built HADES. So as mentioned, HADES is a cyber adversary emulation app designed for situations where you just don't have the time or money to coordinate a red team. Or to steal Bug Crowd's phrasing earlier, thanks. It's an Op4 as a service, right? Thanks, I'm definitely going to be using that. It's free, open source, and containerized, built to run anywhere, all right? It doesn't just have to be for the military, by the way. It can be used for anyone who wants to train wherever you are, all right? HADES gives cyber defenders the ability to create realistic training scenarios on demand, on their own networks, with minimal resources. With HADES, training stops being rare and expensive and becomes routine, accessible, and realistic. Also, if you're interested, that is the GitHub link. It is under a group that I call Death Labs. That's not a company. That's just something I made for a separate project that HADES was designed to interact with. So yeah. And apologize if it's kind of dark with the theming, but that's just who I am. All right, so I briefly explained what is HADES. Let me tell you about what it can do. If it's not obvious with the slide, I'm using the Modern Attack Framework as my attack methodology. I really wanted to just make things easy on myself as a one-man band, just as a one-person development team. So I decided to go with Nmap and Metasploit for initial access and reconnaissance. Nothing fancy, obviously. With that being said, I would love to get some help in adding more tools or RAG capabilities. In particular, the next thing I work on integrating is GoFish for that social engineering experience. Believe it or not, on closed restricted networks, you can still conduct social engineering. So that is the thing. I'll discuss this later in my demo here in a second, but there's two types of targets that you can have HADES go after. One is a machine, another one is a persona. So with using GoFish or a tool like GoFish, you can go after a persona. For example, if you want to go after a VIP or maybe a CEO or maybe a commander, maybe go after the files on their desktop or the documents folder. That's the idea. That would be a type of persona. And then another option would be a machine. But again, this will make sense during the demo. All right, so now I just want to quickly talk to the architecture that makes up HADES. In particular, I'm going to focus on, well, it was gray, but on the screen here it's showing up as white, but pretty much the dotted box. That's what I'm going to do a deep dive on here in a second. HADES is self-contained. Again, it is containerized, so it doesn't create your environment, it participates in your environment. So again, we're gonna step in and zoom in on the architecture of HADES. All right, so just imagine that you are a training facilitator and you're trying to put on a blue team training exercise, right? So you open up a web browser, you go to the HADES front end, you fill out a very simple form. It's constrained for a reason. We wanted to make it easy on the white cell to put on this event. We didn't want them to have to think of any type of prompt engineering or any type of penetration testing. We just wanted someone to say, fill out a form and then initiate the red team attack. So they fill out the form, the front end will take it and relay it back to the back end. On the back end, it's a fast API endpoint that's listening for HTTP requests. Once one is received, it will invoke two AI agents. Those agents are, one is a planner, another one is a operator. If you're curious, the agentic framework that I'm using is AutoGen. And if you're especially curious, I'm using AutoGen 0.2, not 0.4. I'll eventually swap that out. Anyways, so the two agents get fired up and they start collaborating together to achieve the goal that you set in the form that you filled out. As they are working together to cause effects on the target environment or the target that you picked, they are interacting with the inference server. I have a star there because for the demo, I'll be using one of OpenAI's endpoints, but HADES does have an option to run locally. It's kind of slow because, again, constrained resources with compute, but nonetheless. Also, for the message broker, as the agents are conducting their business, they are emitting messages to the message broker, which is how you see the chat going on the front end. As the user of HADES, you submit the form, you'll get redirected to another page that just shows the chat going with the agents going back and forth saying, I've done a scan, okay, now do some additional enumeration, so on and so forth. So that is what the architecture looks like inside of HADES. Now I want to talk about the different use cases that I thought of. Maybe there's more that y'all might have, but these are the ones that I thought of when I initially made this tool. So the first use case is simulating an external threat. The second one is going to be an internal threat. And the last one's going to be conducting self-development. The third use case is what I'll be demonstrating, again, given the constraints that I have right now. All right, so this is what it looks like for simulating an external threat. You would deploy HADES onto an external network and then run it against your whatever environment you have, whether that be dev, test, prod, whatever you pick. This is for situations where your risk tolerance is very low, but you still want to give your blue team the opportunity to get some reps in and practice their skills. The second use case, again, this is kind of getting after that idea of quote unquote zero trust and assuming that you've been breached and operating HADES within your environment. This was actually the first use case that I thought of trying to get this onto closed restricted networks, putting HADES there, again, to not replace a red team, but just address the fact that we don't have one, but we still need to practice as defenders. And then the last use case is, again, conducting self-development. you would be essentially running it on your own personal laptop, achieving the same idea as use case number 2, but just with less resources. All right, so now I will swap my screens around and do a live demo of HADES. To be clear, this is not interacting with the Wi-Fi network, so you don't have to worry about, is HADES going to compromise your phone or your laptops? It's not set up to do that right now. Maybe later. All right, so trust me. All right, so yep. All right, so again, imagine you are me, right? And you want to put on a training event for a blue team, right? You want to give them the opportunity to practice their skills so they can show that they're proficient, or maybe that just they suck and they need more repetitions, right? So the way it'll work is you have a cyber defense tool. Right now I'm going with another free and open source project called Security Onion. Has anyone, I'm assuming there's a few folks, especially the SANS folks, that have heard of Security Onion? Okay. If you haven't, it is a really cool tool. It is a security incident and event management server. Right now, it's just configured to collect network-based telemetry, but it can also be configured to collect host data. But I don't have that set up. It's just looking for network-based logs using Suricata, Zeek, and a few other tools. So showing you a blank page. There's nothing happening on my laptop right now. Okay. So I'm going to go over to HADES. This is what the UI looks like right now. Very simple. I'm going to go to create, and I'm going to fill out this form. First thing I need to do is name the inject. So I'll just say hack the planet. Again, as I mentioned before, there's 2 target types. You can do machine or persona. We're going to go with machine. I'm going to put in the target ID, which is just the address. Next. And then I have rules of engagement. So we have different goals. And when I say goals, it's kind of basic right now, but the idea is we can kind of add additional goals later. And this is important because on the back end, that's going to dictate what type of multi-agent conversation patterns are selected. So to explain, this is the Python file that defines the different patterns. So if you select scan, it's only going to do the steps necessary to that will have the agents conduct a scan. But if you select shutdown, then it's going to invoke these conversations in this order to simulate a red team. So as you can see, for both situations, both goals, you have a get scenario, and that is where we tell the agents, these are the rules of engagement. So don't do this, or you're allowed to do that. And then it goes into whatever the additional requirements are for the training exercise. So I'll go back to HADES. I'm going to say shut down. Allow techniques, I'll say exploiting known vulnerabilities. And then prohibited is denial of service, right? Because maybe we want the training environment to stay up while it's happening. And then I will submit the inject. So as I said, once you submit an inject, or sorry, I didn't explain what inject was. For those who don't know, what I mean by that is in a training scenario or training exercise, if you imagine training as like a television show, right? You have a season, that would be your training exercise, and then you have different episodes, that would be your training event, and then there's different plot points in a given episode. Those are injects. So in a given episode, I might want to say, do a scan, try and shut down this box, gain access to this identity, so on and so forth, all happening within one portion of the overall exercise. So this is one inject that's happening. As you can see, we're connecting to the backend via WebSocket, and then the planner and operator are talking to each other without me having to get involved as a non-AI training facilitator. A lot of times you'll just get some retired infantry guy who's just hosting the event. So they're not very technical, they're just responsible for putting it on. So we made it easy for them, we as in me, made it easy for them and just provide this UI experience. As you can see, one of the first messages is it's telling the LLM what are allowed and prohibited techniques. This is what I selected, exploit known vulnerabilities, and then I said, hey, do not do DOS attacks. Then it proceeds through the attack chain saying, hey, invoke your tools. It was important that I baked in the ability to check, see if there's any open shells. Maybe I already have access to a box. So that's the first check that we do is say, hey, do you have any open sessions, any open interpreter sessions on a box in this network? So it does that. It does a tool call to MS console. Looks like there was a error. I mean, that's fine. This is a live demo. Nonetheless, I think you guys get the idea. Actually, yes. All right. So nonetheless, it's still the LLMs work together to still get past that point of interacting with the tools it has. So we see that there was a IMAP scan just identifying open ports. Looks like there were some more errors with interacting with that tool. Let me go back to Security Onion. And now we have some alerts. So as a cyber defender, I don't have to focus on doing red team stuff. I could just wait for the guy running the event or the person running the event. Say, hey, Vic, there's red team activity. Go ahead and conduct your incident response in the event. So that's the idea. That's the problem that I was trying to solve with HADES. Something I want to point out is the way that HADES works is it's not so much about how well it can compromise a box. It's the fact that there's someone on the network trying to gain access to it and trying to go after our crown jewels in our environment. That's the main problem I was trying to solve. I can always go back and actually get a legitimate data set or build my own model and do that. I just didn't have the tooling or the scaffolding to solve the problem that we were having in the military. So, but pin your questions. That concludes my presentation.